So in this problem, consider n moles of an ideal monatomic gas placed in a vertical cylinder. The top of the cylinder is closed by a piston of mass m and cross section A. Initially, the piston is fixed and the gas has volume V0 and temperature T0. Next, the piston is released, and after several oscillations came to stop. Find the temperature of the gas at equilibrium. Okay, so in this problem we have a piston. So here I have drawn a piston. So it is a piston. Initially this piston is fixed, and that temperature of the gas inside is T0 and volume V0. Okay, and now we have released the piston and it undergoes several oscillations. So we have to calculate that what is the final temperature of the gas at equilibrium. So let us now proceed to the solution. So in the problem, here is given an ideal monatomic gas. Okay, and we know that the ideal gas equation is PV equal to nRT. Here P is the pressure, V is the volume, N is the number of moles, R is the gas constant, and T is the temperature. I shall denote this equation as equation number 1. And so now when we open this piston, it will undergo several oscillations. Okay, so at equilibrium, the force on the piston will be equal. So first of all, at equilibrium we have to calculate that what are the forces acting on the piston. So the forces are mg. Here m is the mass of the piston. Also there is another force from the outside. It is nothing but P0A. Here P0 is the pressure from the atmosphere and A is the area, because we know that pressure is nothing but force into area. So force is nothing but pressure into area. So in the piston there are two forces, number 1 mg and number 2 is P0A. So at equilibrium P0A plus mg should be equal to the force that the gas which is inside the piston is exerting on the piston. So basically here you see that we have a piston like this. Okay, so so there is a gas inside the piston. The gas will also shall exert a force on the piston, and the force will be nothing but P times A. Here P is the pressure inside this piston and A is the area. So at equilibrium the force exerted by the piston should be equal to the force exerted on the piston by the gas. Okay, so it's nothing but PA. Okay, so so at equilibrium this equation has to be satisfied. This equation implies that the pressure exerted on the piston should be equal to the pressure exerted on the piston by the gas. So the above equation implies that the force exerted on the piston by the gas, that is PA, should be equal to the force exerted by the piston on the gas, that is P0A plus mg. Now, as the gas inside this is an ideal gas, piston by the gas, that is PA, should be equal to the force exerted by the piston on the gas, that is P0A plus mg. Now, as the gas inside the vessel is an ideal, then equation 1 and equation 2 must have to be satisfied equally. So now we shall find the value of P from equation 2, and so here we can write P is nothing but P0 plus m by A times G. Okay, and we shall now put this value of P in equation 1. So we get P naught plus M by AG times V is nothing but nRT, and we shall put this as equation 3. So now we shall assume that the above system is isolated, so LQ would be equal to 0, and LU is nothing but minus LW. So here the change in internal energy is nothing but N CVT minus A naught, and EW is the work done by the piston. So so as we know that the work done is nothing but force into displacement. So it is the force which is acting on the piston, and X is that displacement. So if we take a outside, then X is the displacement, A is the area, then it is nothing but the volume. It is nothing but the volume. Okay, so this volume is nothing but the initial volume minus the final volume. So here it is the final volume minus it is the initial volume. So now we have the equation for internal energy, and we have the equation for work done. Now we shall equate both the sides, and here's an important thing. We know that for an ideal monatomic gas, CV is nothing but T by 2R. So we have put and we shall solve the above equation, and we shall take the help of this equation, and we shall get the final temperature of the gas inside the piston, which is nothing but it is expression of temperature of the gas after equilibrium is established.